In linear regression, we define a function of a line to predict y given x. This is done by determining the weights parameter such that it minimizes the mean squared error between the predictions and the targets. Let's now show that the same exact function of a line can be derived with maximum likelihood estimation. Basically, we will want to maximize the probability of y given x. This means the conditional probability. Let's define this probability with a Gaussian distribution where y hat is a function of a line as described above, but now it predicts the mean of the Gaussian. In this example, variance is less relevant, because the probability density function of a Gaussian evaluates to its highest value at its mean. Maximum likelihood estimation would then look as follows. We would want to find the weights such that they maximize the probability of y given x. Let's substitute the notation with its definition. We can then use the product rule to simplify the logarithm. We now see that the left term is a constant and it can be moved outside of the summation. As for the right term, log and exponent cancel each other out. Inside the summation, we are dividing by a constant, so that can be moved outside of the summation. Basically what we have now is we are subtracting the summation from a constant. To maximize this whole thing, we would have to minimize the summation. If we compare this summation with the summation for the mean squared error, we will see that they are the same. Hence, the resulting weights will also be the same.